lesson, we begin a new unit, our last one of the year, on the Pythagorean theorem and irrational numbers. In this first lesson, we'll look at tilted squares to start talking about the area of squares, the area of tilted squares. And our learning targets are to calculate the area of a triangle. You'll see how that comes into play in a moment. And calculate the area of a tilted square on a grid. Go ahead and get started on page 165 and talk about what we discussed with the activity in class today. We had two learning targets: calculating the area of a triangle. Calculate the area of a triangle. And I'm going to just remind you that the area of a triangle is half of the area of a rectangle, or 1/2 the base times the height. And our other learning target is to calculate the area of a tilted square. It's easy to find the area of a square sitting on the ground. Oops, tilted square. But there's a technique that we can use for finding the area of a tilted square on a grid. And there's actually two methods that we're going to use: decompose and rearrange, and surround and subtract. We're going to do, I'm going to show you how to do decompose and rearrange, and we'll do one example with that. And then we'll do the same with surround and subtract. I'll show you one, and then we'll try one more with that. Let's start with decompose and rearrange. And you see this tilted square here. And what we're going to do with this method is break the inside of this shaded region into 4 congruent triangles in a square. Break into 4, I'm going to use the symbol for congruent, that equals sign with a squiggle. I'm doing a lot of shorthand here. Congruent triangles, and probably 1 square. So for this technique, I'm going to really focus on these 4 vertices. They're going to become the corners of my triangles. I'm going to start by putting my pen on the left vertex, and I'm going to come straight horizontally in on this line right here until I'm even with this other vertex. That's going to be the other corner of my triangle. I'm going to come straight up and make a little right triangle right there. So there's my first triangle. All the other triangles I'm about to make are going to be congruent to this one. For the second triangle, I'm going to start at the top and do kind of the same thing. I'm going to come straight down into the square until I'm level with the next vertex on the right here. And I'm going to come over there. So these are a little offset from each other, but trust me, they're congruent. Then I'm going to come to this vertex on the right, and I'm going to come into the square again until I'm even with this vertex on the bottom. I'll come straight down. And then there's just one last one to do. Start with this vertex on the bottom, and come up into the square until I'm level with that last vertex on the left. And you get what's this pinwheel shape. So I've got my 4 congruent triangles, and you can see this one little square in the middle. And the square in the middle is going to be easy enough to find the area of, because it's sitting on its bottom here. It's not a tilted square. I can already tell you that the area of that is just 1. But let's look at these other triangles. The good news is if you find the area of 1 triangle, you really have the area of each of the triangles. So there's my triangle. I know that the area of a triangle is 1/2 the base times the height. So let's count up the base and the height. The base is 1, 2, 3 squares long. The height is 1, 2, 3, 4, if I want to get all the way to the top here. So then the area of that triangle is 1/2 times 3 times 4. Now it doesn't matter what order I multiply these 3 numbers. I could multiply 3 times 4 and then cut it in half, which is what I'm going to do. 3 times 4 is 12, and half of 12 is 6. So that's 6 square units. So I know that this is 6 square units, this is 6 square units, this is 6 square units, and this is 6 square units. I'm going to write a triangle there so I know that's the area of my triangle. A lot of areas going around here. So the area of my tilted square, make a little diamond there so you know I'm talking about the tilted square now, is going to be, well, there's 4 of those triangles, and each one of those triangles is 6 square units. So I'm going to take that area and just multiply it by 4 for the 4 triangles. And then I've got this square in the middle. It's just 1 square unit this time. So I've just taken all the pieces that are inside this square and figured out all of those areas. When I add them all together, I get 25 square units for the area of that tilted square. We're going to come to surround and subtract in just a moment, but let's practice this one more time. So I'm going to use that first strategy here for square E. I would recommend that if you feel like you know what you're doing, try square E on your own, pause the recording, try it on your own, and then turn the recording back on and see if you did it the same way that I did it. Go ahead and pause it now and start back up when you're ready. If you started this back up, hopefully you made these 4 triangles. And if you made them correctly, all 4 of them are congruent, and you're left with this easy to figure out square in the middle. The length of the bottom here is 1, 2, 3, 4, 5. The height of this triangle is 2, so the area is 1/2 times 5 times 2 for the triangle. Let's see, that's 10, half of 10 is 5. So the area of this is 5, the area of this is 5, 5, 5, and this square in the middle has 9 square units. So the area of that tilted square is going to be 4 times the area of one of those triangles, because there's 4 triangles, plus that square in the middle. So 25, oops, I feel like I didn't do that right. 25 plus 9 I'm an idiot. Sorry. I knew there was something wrong. It's not 25. 4 times 5 is 20. Your math teacher knows how to multiply. So it's 29 square units. All right. So that's one method we can use, decompose and rearrange. And the second method, instead of adding up stuff on the inside, we're going to draw a pretty square around this tilted one and subtract triangles off. We definitely still need to know how to find the area of triangles. So let's try the surround part of surround and subtract. Again, I'm going to pay attention to these 4 vertices on the tilted square. And I'm going to draw a square around this that touches all of those vertices. Might have been easier with a highlighter here, but touching all of these vertices. I'll go back over it in a highlighter. So this square is going to be easy to find the area of because it's sitting flat. It's easy to count how long each side is. Let's go ahead and do it. 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3, 4, 5, 6, 7. I just want to make sure I got that right. So this time we have the area of this square that's sitting on its bottom. It's 49 square units. So I've surrounded that tilted square. And now I'm going to subtract off. Let's see what color I can get here. No, I don't know what color I want. Purple. I'm going to subtract off these squares. If I cut those away, I'll be left with that shaded square. And the good news is that all of these purple triangles are congruent again. So the area of one of those triangles is 1/2 the base times the height. Looks like the base is 1, 2, 3 units, and the height is 1, 2, 3, 4 units. So once again, I have an area of 6. That's 6, that's 6, that's 6, that's 6. And so the area of this twisted black pen, the area of the twisted square is just going to be the area of that big surrounding one, which was 49, minus, and we're going to subtract off these 4 triangles. Each one of them was 6 square units. So 49 minus 24, oh my gosh, ends up being 25. And you'll remember it's the same square that we did with this technique. We just approached it a different way. So they are the same answer. So again, we surrounded this square with one that was sitting on the bottom, and then just cut off all of those congruent triangles. One more time, why don't you go ahead and, if you feel comfortable with this, try it with twisted square F. Surround it, find the area of the triangles that you're cutting off, and you'll be able to find the area. Why don't you go ahead and pause the recording, try it on your own, and see if you end up with what I get. All right, if you're back, I found the area of the surrounding square, which was 64. Subtracted off these 4 purple triangles, which were all congruent at 7.5 units. And since there were 4 of those, I multiplied by 4, subtracted from the surrounding square, and got 34 square units. All right. There's a few last things to point out. Which of these squares must have a side length that is greater than 5 but less than 6? Greater than 5 but less than 6. And explain how we know. Well, if we had a side length that was 5, then the area would be 5 times 5, or 25. If the side length was 6, should have made that a little bigger, then the area would be 36. Well, we just spent some time finding the area of these, that red number. So I know the area of square E was 29 square units. Well, that area must fall between 25 and 36. I'm not sure exactly where it falls, but the area is between 25 and 36. So the side length must be between 5 and 6. So that has a side length that's greater than 5, but less than 6. Let's look at the other one. This one's 34 square units. Well, it looks like that one's between here as well. Again, 34 is still between 25 and 36. So if the area is between these areas, then the side length must be between 5 and 6. So both of them have side lengths between 5 and 6. Not sure exactly what they are, but I know they must be. So in summary, if you don't know the side length of a square, you can find its area using one of those techniques above. I'm going to say see above techniques. We could write out a description of them, but I think the examples that we did up here is sufficient. All right, so good luck with the homework and using these techniques to find the areas of tilted squares.